So now we start to this training, and today this first topic is a introduction of Huawei Smart PV plant solution. So for this course, we have three objectives. So first is understanding the industry trends and also the clean challenges. And the second is understand the main features and the value of Huawei smart PV plant solution. And the third part is the difference and the advantage between Huawei and other vendors. So so we started introduce the whole solution. So firstly, part is the challenges. First from the whole the trade of this PV market. So the whole industry have been driven by three sources. So firstly is the carbon neutral. This is also related to the different the government and the countries, the regions. So this is the first driving source. And the second is about the energy security. So this one is very important. So everybody from the China and Europe all focus on this energy security issues. And the third part is the commercial value. So now PV already been approved that is the one of the lowest LCOE, the generation technologies. And LCOE continue breakdown and keep the low level. So we estimate that in 2027, the PV technologies will become the world's first the generation technology. So this is about the market part. And second is not only from the generation side, but also for the user side. So both are moved to the green, the renewable energies. So you can see that from the generation side, the China and also the advanced economy, include the Europe and also America, all support use this PV, the renewable technologies to build the generation, the plant. And also in the user side, we can see to 2050 will be over half of the electricity will come from the renewable energy. So especially like the transportation already change. Everybody will know, see that all the electronic car, are running on the road. So this is the trade. So this marketing is very huge and increase very fast. So this is the first one. And secondly is talk about the challenges. So we can see that the LCOE, as I mentioned, is continually breakdown and will keep the low level. So that's benefits to the whole industry. But at the same time, it also faced many challenges on the lower energy yield and also the lower the reliability, like some of the faults and the broken of the devices and even some accidents. And the third part and another reason, another scenario and the challenges is that there is a because the PV plant is booming, so it have been built in many different area and scenarios. So include all the floating, solar, and some in the desert, and some in the high altitude the place. So that's also bring the challenges to the all the system. So that's also influenced that the LCOE. And the third challenges is about the is about the whole the challenges is about the grid, because it's the renewable technologies or current source. It's not the voltage source. So that's if the penetration rate is become high, like over 30%. So that's where bring the challenges to the grid. So the grid will, you can see like Germany, Spain, all have decreased quickly about the grid strength, and also in China. So this will bring many challenges that for the grid stability problems, such as the SCR, breakdown, so easy to have the problems. And secondly is the high voltage right through. Yeah, this fault happened. And the third one is the power qualities. So many the power qualities from the PV plant give the harm to the grid. That's make the grid is not heals. And the fourth part is the wide frequency oscillations. So this one because many like the long distance transmission of the grid, that's also will enhance this part of the problems. So that's the third challenges. And the fourth challenges is is about the security of the plant itself. So you can see that on the DC side, there is a actually DC side the province normally occupied over 70% of the total province. So like the ground fault, like the DC reverse connections, and also the electrical the installation fault, and also the terminal and the terminal contact fault. This all brings the the risk to the whole the plant, like the fire accident, and also influence to the whole the benefits of the plant. So this is the main four the challenges. So next I will introduce our Huawei the end-to-end solution of the PV plant systems. So you can see that. So Huawei can provide the PV controller, the inverters. So mainly now is the 330 KTL, and also we can provide the STS, the transformer, and also we support from the management platform EVMS and the communications unit, the SACU, and also the SPVC, which is a smart plant control the device. So based on this, our solution, so you can see we meet all these challenges. So first, from the better investment, so we provide the optimal the BOAs. BOAs is the balance of system. So these parts we reduce the cabling and also the pole, and also compared to other traditional solution, we can provide the higher yields. So we have many the test the report from the different sites. So for Huawei solutions, is more than 1 to 3% yield compared to other traditional solution. And the third part is the smart operation and maintenance. So this one we have the IV and also the CV solutions dialysis, and also because we are string inverter, so more we can connect more the digital technologies together. So this also we have more data to support the operation and the maintenance. And of course, the safety and the reliability is the base of the whole power plant. So we can see that we have many patented technologies to guarantee the DC and AC side to be safety. And the last part is the grid supporting. So Huawei, all the KPI of the output power is much better than the other traditional solutions, and especially can meet the request of the grid standards. So this is the first part, the features like the operating optimal the BOS. So this is the 9 megawatts the array. So we can compare to the traditional or other solutions. So Huawei use the cabling, the AC cabling is 300 square millimeters, and why the our other vendors needed to use over 400 square millimeters. So based on this one, we can calculate the whole array. So we can see we save 0.33 the cents per watt. So that is we save the more the BOS, and at the same time, for our inverters 3 are 30 KTL, it's the world's highest the power density inverters. So you can see our size is smaller than others. So based on this one, we can set up just under the pole, under the module, uh, uh, under the module and on the pole. No need to add one more pole to set up our inverters. So this part is also save the BOS to 0.06 cent per watt. So totally, you can calculate that we're saving 0.39 cent watt per watt. And for the higher yield, yes, so we increase the yield by from 1% to 2%. So the reason is that we provide the stable the power generation in different the environment and the temperatures. So we can see that we keep all this power in different the temperatures, but for the other solutions, so there will have the derating, and even announced that they can have the more power than Huawei, but the derating is is too much. So for example, like the 30%, 30 degrees, it start have 5% of degrees, and the 40 degrees is where I have the 60.5 percentage. So the higher the temperature, the more the derating. So this is because the use the IGBT, the use the IGBT is too much, is overload of the IGBT. So that they don't have much tolerance on the temperatures. And also this derating, so we also calculate that based on the 100 megawatt. So the yield loss is 1.48% by derating. And the third one is the smart OIM. And of course, with this one, we also have many benefits. So compared to the traditional solution, we can see the use like the fines, because the design of the architecture is the use the fans and the vertical the air flows. So that will bring much the dust and also the humidity. So you can see there is so many dust on the fence if you open their inverters. So that's they have to send the staff to maintenance at least twice a year. But for Huawei, we use our smart self-clean fan. So based on this one, when we have some conditions, for example, if there's not much the yield, so we will start the uh, the opposite to rolling the fan. So that will bring all the dust out of the inverters and the fans. So this one, we will save the O&M and without any the interruption. So here is one calculation is around like 250,000 US dollar, totally for 25 years. Yeah, this is a video. You can see that it's a normal rotation, and then it will reverse to remove the dust. And also for our STS with the transformer. So for traditional the station, if there is any problem happen or any the alarm, so it will close and shut down. So that's the that's the bring also the O&M problems and also the yield, it influence the yield. So for Huawei, we use our data unit, the Saku, and we have many the connection sensor in our station transformer, so we can connect the four signals of the different the components. So you can see here we have list some part of the main part of our signals, like the status of control, and also the analog signals and the protection signals. So this status were connected together. So based on this one, even we can control very accurately. So if the we can judge that if the alarm not so serious, so we'll keep the STS continue running. So that also support the uh, the the customer have the more years, and at the same time we keep the safety and the security, and we also can support our operations staff can solve the problems quickly. And also for the whole the OIM, we have the PV management with the multi-level management for the whole the plant. So we have plant level detection, array detection, device level detection, and the string level detection. So this is the can give the whole measurement to our the operators and the maintenance staff. And also we use our digital technologies to support to analyze the fault of the whole the solution. So you can see that the first part is the efficient of variation analysis. So this one is quickly tell you which the module have the problems, which the you can see the string, the whole string, which string have the problems, because it will judge different level of the power generation. So it can quickly judge that if if the the power generation reduce up to 20%, that's will be critical and uh, needed to find the fault quickly. So this scan also very quickly. So this one is the first step to identify which string have the problems. And secondly, we use IV curve, the diagnosis, we call the 4.0. So this one is can online and fraud detection, the whole string. So you can see that after we know which string have the problems, we use IV curve to scan, and the IV curve can quickly find the which type of the problems the module have. You can see here already list all the different kind of the scenarios and the problems, and compared to the other vendors, we have the full portfolio and also have the more accurate rate. So this is some case we already done in the different the scenarios, including the mountain and also the temples and also the on the on the sea and on the water. So we already implement over 20 gigawatt. Uh, is a big amount. So so this is some of the real case that we get in Colombia and also in Malaysia. Yeah, we get the certification and the signature from the customer. That so, for example, in Colombia, we improve their PR increased to 6%. And also in Malaysia, we support them to save the whole the O&M time up to more than 2,000 hours. And also this is also one the OPEX OPEX the analysis, yeah, from our customer. So after their real project calculated, so for Huawei solution compared to other vendors, we have the 26.6% time saving on the O&M. So this is have the report to support. And also for safety and reliable, this is also very important. So this we have the patent technology to use it. But if our vendor, our other vendors mention that they can support, that is fake. Okay. So the first part is the smart screen level disconnection. So this one will guarantee the DC side um, uh, for example, some fault like the string fault connections, and also the DC input, the current reverse flow, and also the inverter, the internally short circuit. If you have such kind of the problems, so we have the switch will close quickly. So for each our inverter, we have two switches. So this one um, can switch half. If they have problems, they can switch half of uh, uh, the inverter. So this is can guarantee there is no file if you have this fault happen. If you compare to other vendors, then maybe they cannot support, and then if they have such kind of the problems happen, it will be broken and even have the file. And also this is another the patent technology we call the smart connector. connector, smart connector level disconnection. So this one, we can see the connector is either loose, and will cause the high temperature, and then it will have the fire. So that also the normal fault happened in the plant. So while we use our this technology, which will have the sensor to detect the temperature of the connector. So based on that one, if over like the 85 degrees, so we will give the alarm and shut down the inverter. So that also guarantee there is no problem, and also the accident happened in the DC side. And also we have the MPPT, the lever to scan and diagnosis. There is any insulation problem happened in the different the MTBT the connections. So based on this one, we can see that uh, um, when the inverter started running, it will go this the functions. So if they find the insulation problems, so it will tell you is which MPPT have this problem. So that's is easily to allocate the fault string. And compared to the our other vendors, they will like some have the only one MPPT and also a big amount of the array. So it's very hard for them to find which string have the isolation problems. So that's the uh, uh, this technology will improve the whole the O&M the efficiency also. And also for the communication, so we have the highest PLC, the communication. So we use M bus. We have broadband M bus, the chip. So our bandwidth, you can see our communication of the bandwidth is much higher than the traditional the solutions. And also we get the certification uh, based on our third parties, the report. So we have the highest level of this M-bus, and also we can provide the longer transmission distance up to 1,000 meters, and this can support the larger array, like 9 megawatts. And also the reliability is very important. So for Huawei, we do the reliability design. So from design, we all use this pre-fit prepping process. So if you compare to other vendors, they are not using such kind of the technologies. Yeah, and this one will guarantee the improve the whole reliability by 100 times compared to others. And also our connectors is on board design. So that's one will get the connector very strong and stable, so not easy to lose. Yeah, and also the whole design like the the emissions. So we also design uh, with our simulation and also the models. So this one will also enhance our heat the emission. So that's also improve our the reliability in different scenarios and environments. And also, our design, of course, is based on the IP66 protection grid, and to avoid the dust and the humidity outside. And also, before our product go to the market, we test it in our library, and it have the hash environment, like the temperature over 60 degree, and also like the very high humidity. So and also dust. So this is guarantee our product go to the market is very reliability. So we have the certification report that in one of the plant in Qinghai province in China. So the failure rate is less than 0.5 percentage per year. Yeah, this is what I mentioned. This is the TUV, the certification. So you can see that this Qinghai, the project already run over 10 years. Yeah, so you can see that the availability is 5 nines. Okay, and this is the reference. Also, we have built many benchmark in different areas and the different scenarios. So, for example, in Qinghai, we provide the largest the single PV plant, 2.2 gigawatt, and also the feature is on the water feature and PV plant, and also the high altitude in for example in Sichuan of China, the altitude is over 4,300 meters. Yeah. So and also in the desert in the Inner Mongolia, we also have the big like over 1 gigawatt the PV plant which have the in the desert that have the high temperature and also the sand stones. So this also give the challenges to our solution, but our system running very well during these years. And also for STS part, we bring the highest the standard of the industry. So we successful pass this IAC 20 KA 16 type test is based on the IEC the standards. So it's a guarantee and keep our operator and the staff to be safe. Yeah, and also we are not to use these air cross convections, so that ensures the higher the availability. Yeah, because it's avoid the environment the outside the factors. So that will improve the environment the adaptabilities. And also it's very easy to maintenance. There is no the filters design. Yeah, so easy to maintenance. And the last part is about the grid supporting. So Huawei have many the algorithms and compare and match our hardware. So it's can bring the whole process to support the grid scenarios. So we have the grid sensing and the stability and the fault right through and also the harmonic separations. These different the algorithms. So based on these algorithms, so Huawei the solutions can provide the five the core the grid connection indicators is much better than others. So you can compare the left side and the right side. You can see all the KPIs is much better. So that's will guarantee Huawei inverter outputs the high quality the power and support the grid more. This is also one case that we have passed the Australia the new strict grid code. So Australia actually their the grid is very weak. So based on this one, so it is not easy to pass their grid code. So Huawei started from the 2019 and um, study study cooperate with the local certification and to do the whole the simulation and also the constructions and the test. And at last, we are the first vendors who pass this the very strict the grid code. That also prove that Huawei is the top one to support the grid inverter. And this is another case that happened in China. So this is the low level, uh, low voltage red shoe. So yeah, this is one plant, but it have the two is like the two plant at the same place. So for one plant is from the our other vendors. So you can see that use the centralized inverter is 100 megawatt, and the Huawei use our string inverter and 20 megawatt. So you can see that in 2020, so there is one day they have this uh, the low voltage, the red through. So the central PV plant is have been break down directly, and for Huawei, the inverter is running smoothly. So that's also one the improvements that Huawei in the real side still be the much better than other vendors. And lastly is uh, some our benchmark in the different countries and area, and some is our benchmark which you can visit. So the first one is the Yalong River in Sichuan. This is the biggest the high altitude plant in the world. So its total capacity is over 1 gigawatt, and the locate the of the plant is a very high altitude, as I mentioned, it's over 4,000 meters. So this is the first big plant which have so high altitude, and our inverter is running very well there. And the second reference is in the north of China, is in Mongolia. So we call the Kubuchi Desert. So it's also is very big the plant which have over 1 gigawatt, and in the future it will move to expand to the 8 gigawatt. So Huawei, based on this, the very harsh environment with the high temperature and also the dust state. So we use our technology to support the customer get the higher energy yield and also the safety and reliability and also the intelligent the OIM. And the third one is in Shandong province in China, is near the sea. So Huawei solutions used to the on the whole the sea. You can see all these pictures. So it have the very higher the erosion. So Huawei inverters can support IP66, and the higher is the level, of the C5H. This is the anti the erosion is the highest standard of inverter compared to other vendors. So Huawei is the only one who passed all the certification. So we use these inverters on this project. Is on the sea, and this is the largest plant on the sea scenarios. So also we have, as I mentioned, we use this our patent technologies like SSLD, SCLD, and MPPT level insulation. So these technologies support to guarantee the safety of the whole plant, and also the IV diagnosis will improve the whole the OIM, the efficiency. Okay, that's all my presentation and the training. Uh, Thank you very much.